Okay guys, welcome to our third week, and in this week we're going to look at linear algebra and how we can use matrix notations to solve a set of linear equations. Alright, so just to kick off, if you recall from last week, we were able to calculate what values of x would satisfy the following equation, singular equation, and that is we used numerical methods to solve this. But now we want to determine what values of x, where x is some vector, so say x has n dimensions to it. We want to know what values of x satisfy the following equations. So we may have n number of equations, which are all functions of x, our vector. We want to know what are the values of x that satisfy simultaneously these equations. Now, these equations can be linear or nonlinear, but we're going to focus on linear algebraic equations that have the following form. So we can write a set of linear equations that look like so. There are n linear equations. Pay attention to the notation I'm using in our subscripts here. What do you think that I'm referring to? When I say a n of n, what am I referring to? Sorry, this should be 1. Okay, so here we have a set of constants, a11, an1, all the way to ann, that are equal to some value that we call b. Now that you can see that these are linear equations, but what I want you to look at is that these should be very familiar, this formulation should be very familiar to you. And in fact, you should notice that this actually looks like some type of matrix notation. So we're going to just recap quickly just some basics about matrices, and then we're going to carry on with the week.